Hi everybody, this is Bob, the old ham. I'm going to put this thing in standby. And this is a National NC98. I was at the Goodwill store, saw a gentleman with this in his grocery cart, and I stopped to talk to him since I'm an amateur radio operator, been one for 62 years. So anyhow, I was fascinated by his find there at Goodwill. And so I told him, I said, that's a neat little old receiver you got there. And I said, you're going to fix it up? I thought maybe he might be a ham and going to fix it up. And he said, no, I have no idea what it is. And I said, well, it's a communications receiver. It's very, very old. And I said, if you do fix it up, it's going to take a lot of work. I said, there'll be new tubes you have to put into it. You'll have to have an external speaker. You have to have an outside antenna. There probably will be other parts that are bad too, as well as a good cleanup. And I said, but it'll be a good receiver when you get done. And he says, I don't know anything about that. I don't even know what it is. And he says, you seem to know a lot about it. He said, would you like to have it? And I said, yes, I would. He said, well, just take the cart and you can buy it. He says, that'll be fine. I said, well, thank you very much. So a very nice gentleman. That was at the Goodwill in Granger, Indiana. Anyhow. I got it about a week ago, and I've been working on it since. All the controls here have been oiled with a syringe. You can pull the knobs off on here. They just slide off, except for this one down here. I put one in with a set screw. Anyhow, you slide them off, and I put a little tiny bit of oil on the shafts. This one here, the volume, you could not even turn it. It was so solid. So they all work freely now. The big knob on the center here was bent. Somebody had dropped the receiver or something like that, and the knob just went around and around and around. I took it off. It does have a set screw on these, and I believe it's a like a 1/16 inch Allen wrench. You have to get that one off. Anyhow, I took that off and I straightened it out with a big pair of pliers. That's taking a chance. I could have broken it, but it wasn't usable like it was. Okay, so I got that off. Then I started checking resistors and things in here because I thought that might be my biggest problem. Then I found out that two of the tubes were not the right ones. They may have been acceptable substitutes. I don't know. But I put the original type numbers in and it started working. But then I found out that the CW, when you're receiving CW and using the BFO, it sounded terrible. See if I get something on here. Hear that raspy sounding CW? It's terrible. Anyhow, so I'm listening to that, and I thought, oh, there's got to be something wrong. So I started changing resistors. I found 8 resistors that are way out of tolerance. There's a 150K right back in here. You can see it right there. I've got a red dot on it. That little red dot is some nail polish I put on there. That indicates that I have tested it, and it's within value. But the one that was in there originally, it said 150K on it. It was 275K as measured with my calibrated Fluke digital multimeter. It's a bench type multimeter. So anyway, I did that. I changed a couple capacitors. These are big ones, much bigger than's needed. They were 400 volts in here, and I put these 1,000 volt ones in because that's what I had. Anyhow, changed that. And anyhow, it started working and working pretty good, except I couldn't get it to work on 10 meters. Now, I had checked all the tubes. I went through the whole group of tubes, checked them all. They all checked good. But would you believe the 6C4, which is right under here, would not oscillate on 10 meters. That's the oscillator tube. So I grabbed another 6C4 that I knew was a new old stock, put it in there, and it works beautifully. So don't trust your tube tester always. You may find sometimes that your tube tester says a tube is good, but the only really good way to check a tube is to put in another known good one. So that's what I did, and that got that working. So then I got to looking at the circuit, and I worked in design of electronics amateur radio equipment in the Heathkit Development Laboratory. And so I got to looking at the circuit, and I thought, well, I would not have injected the BFO at the detector stage on this particular receiver, looking at the schematic. So I looked at that and I thought, well, I would have put it in back here on the other side of this transformer. They put it on this side. I would have put it in on the other side, and then I thought about putting it on the grid of the IF tube right here, the 6BD6. That's the number, 6BD6. I couldn't think of it. I had never heard of a 6BD6. All these years I've been in this, I never heard of a 6BD6. Well, you heard how terrible this thing sounded, so I've inserted that right there. I'm using the original capacitor, which is right down here. I'm trying to find it on the, there it is. Trying to get in there so you can see it better. Right there, that little white one. It's a 10 Mickey mic or 10 microfarads marked on it, but that's 10 picofarads now these days. Anyhow, I just took it off from pin 7 of the 6AL5 right here. There's the wire I cut right there. And I leave the wire hanging like that so I can put it back if I need to. And then I ran a wire from pin 1 of this IF tube right back here, which is the grid. And that's this brown wire that you see right there. And I have a little short clip lead on it. So I clipped that to that capacitor. Now the schematic says that capacitor should be 3 picofarads. It's a 10 picofarad. And I know what they were doing. They were trying to get more injection of the BFO because the CW didn't work that good. So anyways, I've got that now. I put it back onto pin 1 back here with this brown wire. It's going to pin 1 of that tube right there, which is in between these two IF transformers. And listen to the difference. And one thing you will notice, it's got plenty of volume now. So I'm just going to connect that. I like the sound of that much better. And I'm going to connect that brown wire then up permanently to that little 10 picofarad capacitor there at this location right here. So all I have to do is put that on there, maybe put a little heat shrink on it, and I think the reception on CW will be much, much better. I've been running it quite a bit like that. I really like it. So I wanted to show you that. I also got in here and I replaced the 5Y3 tube. The tube is still in there, but I disconnected the filaments from pins 2 and pin 8. I wrapped them back on themselves, just folded them back, and I put heat shrink. This is clear heat shrink I shoved on there and shrunk it down so that they don't short out. But that reduces the load on this transformer on the other side by quite a bit. These receivers were built when we had 110 volts AC. Now we got more than that. I'm reading 123 volts here today, and so they run hotter. And that's not a good idea to have those transformers that were designed for 110 running on 123. What I'm getting at here is that by reducing the filament load of that 5Y3 from the transformer, which is considerable, it allows the transformer to run a little cooler. And it does. It just gets warm now, which is real nice. It got pretty hot before I took that 5Y3 tube out. I used 2 silicon rectifiers on each side because the rectifiers I had were not rated at 1,000 volts. I think they were 400 volts. So I put 2 of them in series, and then I put 0.01 2,000 volt capacitors across each diode. That's to prevent what they call diode oscillation, or as they say in German, Diodhausen. It's quite often pronounced Diodhausen in the United States too. And so that's a self-oscillation in the diodes, which causes interference in the receiver. So that's why you put bypass capacitors across each one of the silicon diodes. And I also added two 1000 ohm 3 watt wire wound resistors. I don't even know where I would get some of those, but this was in a box of junk that I had purchased at a Hamfest, and I pulled these two resistors out and put them in there. The voltage that I read here is 275 volts. According to the schematic, it calls for 290 as normal. So I thought, well, a little less than normal doesn't hurt a thing, so it works just great. So I wanted to show you that. And what else? I guess that's it, guys, for right now. The receiver is really doing great. Okay. I just was listening to the CW. What a nice note it is. And like I say, you got plenty of volume. Before, that's about how loud it would go with the volume fully on. And to get a clear note. So you had to bring the receive RF gain control, or sensitivity as it's marked, way down. And I don't have to do that anymore. Really like the way that thing sounds, and I wanted to show everybody that. I'm going to turn it off here. Now this thing is all dusty and dirty like crazy on the top side, so I'm going to have to clean that all out. Anyway, just wanted to show you what I was doing here and what was happening and how well it works. So that's it. It's snowing outside. It's about 24 degrees, and we've got like 12 inches of snow out there on the ground. Some of it is quite old snow, so it's pretty hard, but we got a couple of inches of fresh on top too. So it's nice to have a project like this in times when we are staying inside so much, maybe with the snow, and maybe not with the snow so much as the COVID. But anyhow, it's nice to have a project to work on like that. My wife remarked about that a couple days ago. She said, you know, it's really nice the way you can keep yourself busy working on the radios and things. So I really like that. So ham radio has been a real salvation for me during these times. 73s, everybody, and good DS.